Alright, so this is your first practice test of the semester. We haven't had our first test yet. I always try to make my in-class tests that you're going to take as close to the practice test as possible. There shouldn't ever be anything on your in-class test that isn't just like something on the practice test. And if you come to class, kind of the day before the test, if there's anything that's kind of subtly different between the practice test and the actual test, I'll make some comments in class, so you should know exactly what's going to be on my test. The best thing you can do before watching this video is to try to do all the problems on the practice test. Treat it like it's a test, meaning if you're not going to turn your homework in and come to class, don't use a note card. If you're turning in your homework and you came to class, do it with a note card. And when you go through and watch the video, only watch the problems that you didn't get right. You can fast forward through the stuff that you got right. Alright, so problem 1 gives me some information about a line, wants me to find an equation of a line and write it in slope-intercept form. Problem 2 wants me to do the same thing. So the equation I'm going to use to do this problem is y minus y1 equals m times x minus x1. And I just simply have to plug in values for y1, m, and x1. And all those numbers in this problem are given to me. The m is the slope. The x1 is the x-coordinate of the point that's given. And the y1 is the y-coordinate of the point that's given. So I'm just going to take the numbers that are given and plug them in. I'm going to go y minus, and then in for y1 I'll put a negative 3. And because I have two negative signs in a row, I'm going to put that negative 3 in a parentheses. To the right of the equal sign, the first number I'm going to put is the negative 2 for the m, and then x minus, and then for x1 I'm going to plug a 2. That's the equation of the line. The instructions say to write in slope-intercept form. That implies to solve this for y. So I'm just going to solve it for y by clearing any parentheses and then getting the y by itself. So on the left side, the double negative becomes a positive. On the right-hand side, to clear the parentheses, I go negative 2 times positive x, which gives me negative 2x. And then I do negative 2 times negative 2, which gives me positive 4. Almost have the equation solved for y. To finish this problem up, I just minus 3 from both sides. And when I do that, I'm going to get something that's completely suitable. It's the best answer. On the left side, when I subtract 3, I'm left with the y. On the right-hand side, I'm going to bring down the negative 2x. And when I do the 4 minus 3, I get positive 1. That's perfectly the best answer for problem 1. Problem 2 asks me to find another equation for a line in slope-intercept form. It gives me the point, it gives me the x1 again, and it gives me the y1. It doesn't give me the slope explicitly, but it kind of gives it implicitly. It says we're trying to find an equation of a parallel line, a line that's parallel to the line y equals 1/3 x minus 2. The slope of that line is the number in front of the x, which is 1/3. And because our lines are parallel, it's going to have the same slope. So the number in front of the x here is actually going to be the slope, because it's the slope of a parallel line, and parallel lines have same slopes, or equal slopes. So now I'm just going to use the y minus y1 equals m times x minus x1 formula. I'll have to deal with a fraction here. On the left-hand side, I'm going to put y minus negative 5. On the right-hand side, in for the m, I'm going to plug a 1/3. And in for the x1, I'm going to plug 6. Clear the double negative on the left side to get y plus 5. Clear the parentheses on the right side. I'm going to go 1/3 times x, and that's easy multiplication. That's just 1/3 x. The second multiplication, I left myself some room to do because it's a little bit harder. When I do 1/3 times negative 6, I can do that on my calculator if I'm not comfortable doing that. I could just simply on my calculator put the 1 divided by 3 in a parentheses and then put a negative 6 in a parentheses, and that would be 1/3 times negative 6 on my calculator. It's going to come out to negative 2. So negative 2 is going to be the number that goes after the 1/3 x. I should have known how to do this without my calculator, and I kind of hinted at it. When I showed this by hand work, I wrote the negative 6 kind of small because I'm going to think of that negative 6 as negative 6 over 1, and then I'm going to cancel that 3 from the 1/3 with the 6 or the negative 6. The 3, if I cancel it with the negative 6, I'll divide it by 3 and get 1. The negative 6, I'll divide by 3 and get negative 2. And then I see the only thing left in the denominators are 1, so I'm not going to get a fraction. And what's left is just 1 times negative 2, which is the negative 2. I'm not done, but I'm done with the hard part. I got rid of the fraction. Now I just need to solve for y by minusing 5 from both sides. And I'm going to get something that's perfect for my answer. On the left-hand side, I'm going to get the y when I minus 5. On the right-hand side, the 1/3 x is going to stay. And on the right-hand side, since the numbers have the same signs, I add the numbers and keep the sign. And we'll get 1/3 x minus 7, or y equals 1/3 x minus 7. So that's one formula we need to know for the test. Another formula that we need to know for a test is the standard form of a circle. And the equation, the standard form of a circle, is x minus h squared plus y minus k squared equals r squared. Problem 3, it gives me all the information about the parts of a circle. Specifically, it gives me the radius of the circle, and it gives me the center of the circle, the x-coordinate of the center and the y-coordinate of the center along with the radius. Problem 3 wants me to find an equation of this circle in standard form, and it wants me to sketch a graph. I could actually sketch a graph without knowing the equation, but I'll go ahead and get the equation first because it's easy, and I have the bones here for this. So to get the equation of this circle, I'm simply going to take the x-coordinate of the circle center, which is h, and plug it in for the h. I'm going to take the y-coordinate of the circle, which is negative 1, and plug it in for the k. Again, I have two negative signs in a row, so I'm going to write the second one in the parentheses. And to the right of the equal sign, I'm going to square the radius. That's technically the standard form of the circle. If you wrote that down for an answer, this could be part of your answer. It probably would be better if I got rid of that double negative and simplified the right-hand side. So the standard form, or the standard equation of this circle, this is going to be part of my answer. It's going to be x minus 2 squared plus y, and then the double negative goes to positive 1 squared, and to the right of the equal sign 5 squared, which is 25. This is what I'd expect for part of your answer to the test question that asks me to find the standard form of the circle that meets this criteria. The graphing part's not so fun. To graph the part, I'm going to plot the center, which is the point positive 2, negative 1. So I'm going to make a little dot there, that's the center. And then I need to go right 1, 2, 3, 4, 5, make a dot, up 1, 2, 3, 2, 3, hold it, up 1, 2, 3, 4, 5 from the center. So up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, and left 1, 2, 3, 4, 5. I'm going to mark a bunch of dots, and then I'm going to, the best I can, and you know I can't do that so well, connect these dots with something that looks like a circle. It never really looks like a circle when I draw it, but yeah, that's going to be adequate enough. And it would be nice if I actually labeled that center point of 2, negative 1. But this is supposedly a circle that has a center of 2, negative 1 and a radius 5. And again, I just plot the center, go up 5, right 5, left 5, down 5, connect all those points. All those points are on the circle and with something that kind of looks like a circle. Question 4 gives me the center of a circle and a point on the circle, and it asks me to find the equation. It says you can sketch a graph, but you don't have to sketch a graph. So immediately, I know to find an equation of a circle, I need a center and I need a radius, because those are the three numbers that go in my circle. The center goes on the left side of the circle, and the radius squared goes on the right side of the equation, I guess. So when I go to write my answer to problem 4 is going to be an equation of a circle, and the left-hand side needs to be x minus some number squared plus y minus some number squared, and the right-hand side needs to be the radius squared. Well, the left-hand side is easy for me because I know the center of the circle, and what goes in the first parentheses is the x-coordinate of the center of the circle, which is a 3. What goes in the second parentheses on the left side is the y-coordinate of the center of the circle, which is 1. The only thing I need to do to finish this problem up is to get the number for the right-hand side, and the right-hand side isn't just the radius, it's the radius squared. So I need to figure out what the radius is, and I don't like the way I do it in the video, but I'm going to do it that way again because I don't want to record that whole video again. My hint is, let's sketch a graph of this circle the best we can and see if we can kind of reason out what the radius is. So here's my circle center. The center is the point 3,1, and in addition to passing through having a center of 3,1, it also goes through the point 5,1. So the center is the point 3,1. It's not a point on the circle, it's right in the middle of the circle, and it passes through the point 5,1, and so the circle looks, oh gosh, something like that, kind of like that. And my goal is to figure out what the radius is. The radius is the distance from the center to the edge of the circle. If you can't tell that the radius is 2 by looking at that, I can use the distance formula to find what the radius is. So the radius is the distance between the center and the point 5,1. And so I can find what the radius is by just using the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so I can find out what the radius is by just taking the numbers that I have from the points and plug them into the equation. I'm going to use for x2 the x-coordinate of that 5,1 point, and I'm going to use for x1 the center's x-coordinate. So the distance between those 2 points, I'm going to start off by going 5 minus 3 squared plus, and then for the y2, I'm going to plug the y-coordinate of the 5,1 point, and then for the y1, I'm going to plug the y-coordinate of the center. This is going to be the radius, so actually probably instead of saying distance in this problem, because the radius is the distance, I can say radius here. Now let me try to clean this up. Inside this parentheses, this is 5 minus 3 squared, which is 2 squared, and that's plus 1 minus 1 squared, which is plus 0 squared. This is going to be the square root of 4 plus 0, which is the square root of 4. And so the radius comes out to be the square root of 4, which is 2. My formula needs the radius squared. So I'm going to have to figure out what the radius squared is. And the radius squared I get by just squaring the radius. And the radius squared is going to be 4. So in my equation for my answer, I'm going to plug a 4 in for the right-hand side, because the right-hand side doesn't have the radius, it has the radius squared. Alright, so one more circle problem and then we'll move on to other kinds of problems. The last circle problem, I think is the hardest problem. Wants me to rewrite the equation so I can kind of figure out what the center is and the radius is, and then sketch a graph. To do this problem, I have to write the x terms close to each other, the y terms close to each other, and leave a gap between the x's and the y's and the y's and the equal. And I have to add some number. I'll call this one the first number, constant 1, to the x's. And I need to add some number to the y's. I'll call that constant 2. And whatever number I add on the left-hand side to keep the equation balanced, I need to add it on the right-hand side. Super easy to figure out what those numbers are. You just take the number in front of the first power term for that letter, divide it by 2, and square it. So the C1 is going to be 6 divided by 2 squared, which is going to be 3 squared, which is going to be 9. And then the C2 is going to be the number in front of the y to the first power term divided by 2, and then it's squared, which is going to be 16. So I'm going to rewrite the left-hand side and get rid of those c's. I'm going to change the first c to a 9, and I'm going to change the second c to a 16. And on the right-hand side, I'm going to add the 9 and the 16 after the 11. Once you get the c's replaced, you need to do some extra algebra. The group of x's you need to factor, the group of y's you need to factor, and on the right-hand side you need to add up all the numbers. So on the left-hand side here, this x squared plus 6x plus 9 factors into x plus 3 times x plus 3. The y squared plus 8y plus 16 factors into y plus 4 times y plus 4. The right-hand side, if I add up the numbers, I get 36. Part of the instructions said rewrite the equation so it's written in standard form. A correct answer for writing it in standard form could be x plus 3 squared plus y plus 4 squared equals 36. I'd be completely content with that for an answer. That's probably the answer I wrote on my key. Technically, the standard form is x minus some number squared plus y minus some number squared equals to r squared. Having it written the way I said is fine for the answer. You don't see the minus signs in the parentheses, and you don't see the squares, the square on the right-hand side. The alternative way to write this is to make any pluses in the parentheses into double minuses, because double minuses are equivalent to pluses. And you can square root the number on the right-hand side and write it with a square. So these would both be correct answers for rewriting the equation so it's written in standard form. The top one just seems more natural because that's what the algebra gives me. The bottom one might be more helpful when we go to finish this problem up, and we have to finish this problem up by sketching a graph. In order to sketch a graph, I need to know the center and I need to know the radius. When the parentheses have the minuses in it, then the numbers after the minuses are actually the center. So in this particular circle, when I go to sketch a graph, the center is going to be -3, -4, and the radius is the square root of that number, which is at 6, because the formula has an r squared. So when you see the squared there, you actually have the radius. So to finish this problem up, I'm going to have to pull out another sheet of paper. I'm going to sketch a graph, and the center is -3, -4, the radius is 6. If you have the parentheses with plus signs in them, without the minus signs, you have to change the signs of the number to get the center. And if the right-hand side doesn't have the square, you have to square root to get the radius. So to finish up problem 5, I'm just going to sketch a really awful graph of a circle that has a center of -3, -4. So negative 1, 2, 3, negative 1, 2, 3, 4. So that's negative 3, negative 4. There's my center. And I need a radius of 6, which means I need to go up and down, left and right 6. So I'm going to go right 6. 1, 2, 3, 4, 5, 6. Make a dot. It doesn't really matter if I write the number ticks on the x-axis. And I'm going to go left 6. So 1, 2, 3, 4, 5, 6. Again, it doesn't matter if I make the dashes on the x-axis so much. I just counted 6 to the left, 6 to the right. Now I'm going to go 6 up. So 1, 2, 3, 4, 5, 6. And then the down. 1, 2, 3, 4, 5, 6. I'll go off to my screen. And again, I don't really need to mark the y-axis up so much, but there's all my points, and now the best I can, I'm going to connect those with something that looks something like a circle that actually goes through the points. And that would be a completely adequate answer for the sketching the graph part of number 5. I probably would be nice if I actually said that this is the point negative 3, negative 4. Might have been nice if I wrote some numbers on the axes like negative 1, negative 2, negative 3, negative 1, negative 2, negative 3, negative 4. On the test, you'll be given you won't have to sketch the whole graph per se. The axes will all be provided for you with numbers on them. You'll just have to do the drawing and marking the center. All right, done with circles. Now on to intercepts. Intercepts are easy to find because you just plug in zeros. So I need to find the x-intercepts for number 6. To find the x-intercepts, I plug in 0 for y. I'm going to take the equation x squared plus y equal to 9. Plug in 0 for y. This is going to give me x squared equals to 9. You can solve by square rooting or you can solve by factoring. If you solve by square rooting, you better do a plus or minus. I'm going to solve by factoring so I don't slip up. So I'm going to minus 9 from both sides after I got x squared equal to 9. And then I'm going to factor. That factors into x plus 3 times x minus 3. Then I'm going to set the x plus 3 equal to 0 and the x minus 3 equal to 0. For the x plus 3, I'm going to subtract 3 from both sides and get x equal to negative 3. For the x minus 3, I'm going to add 3 to both sides and get x equal to positive 3. When I go to write my answer, I need to write them as a point. And x-intercepts always have the opposite letter as a 0. The opposite letter of x is y. So for my x-intercepts, I'm going to write the point negative 3, 0 and positive 3, 0. So done with that part. The last thing I need to do is find the y-intercept, and always the opposite letter has a 0, so the answer for the y-intercept is going to have an x equal to 0. And the algebra for the y-intercept is to plug 0 in for x, so I'm going to go 0 squared plus y equals to 9. This is going to cancel out and become a 0. This is just going to give me y equal to 9. The y part of the y-intercept is 9, and I'm just going to say the y-intercept is the point 0.09. And all there is to do for 6. Seven's another x and y intercepts. Let me do the x-intercept first. To do the x-intercept, you put 0 in for y. If you're clever, the algebra that you do is you only set the numerator equal to 0. I'll not be so clever, but I'll still get the right answer. So now I have a fraction set equal to 0. The nicest way to solve this is to write the right-hand side so it's also a fraction by writing it over 1. And then once I get it set up like that, I can cross multiply. When you have one fraction equal to another like that, you can cross multiply. Cross multiplying up, I get 1 times x squared plus 11x plus 10. And cross multiplying down, I get 0 times x minus 2. The nice thing about this, easy multiplication there, 1 times anything is itself, so you get x squared plus 11x plus 10. And on the right-hand side, 0 times anything is 0. When you're going to find the x-intercept, if this would have been the first thing you showed and the only thing you showed to start was setting the numerator equal to 0, that's better than doing all this work. Anytime you're asked to find the x-intercept of a fraction, you can ignore the denominator and set the numerator equal to 0, and you'll get the right answer with a lot less work. For this problem, there's a square, so I need to factor it. There's no minuses, so I don't have to worry about any minuses in my factoring. I don't have to worry about any bottoms up because there's no number in front of the x squared. My last need to multiply to 10 and add to 11. That's going to be 10 and 1. Once I get it factored, you set the factors equal to 0. When you set the x plus 10 equal to 0, you minus 10 from both sides will give you x equal to negative 10. When you set the x plus 1 equal to 0, you minus 1 from both sides and get x equal to minus 1. When I go to write my answer for the x-intercepts, always the opposite letter is 0. The x part of the x-intercept is negative 10 and negative 1. The opposite letter y is always 0. So that's part of my answer. And then the last thing I need to do is get the y-intercept. The y-intercept, the x part is going to be 0. And then to get the y-intercept by hand, I'll go to this equation, I'll leave the y alone, and I'm going to take all the x's and make them 0. So I'm going to go 0 squared plus 11 times 0 plus 10 over 0 minus 2. And then all the pieces that have 0 are going to turn into 0. So you're going to get y equals to 10 over negative 2, and that reduces to negative 5. When I go to write my answer, I write it as a point. I plugged in 0 for x, always the opposite letter is 0, and that should be perfectly fine for the answer. 8's the messy problem, and I know how I like to do it, and I know that students resist all the time how I like to do it. So let me just do this how most students do it on the test, even though it kind of just seems harder to me. To find the x-intercept, I'm going to plug in 0 for y. So I'm going to go 3 halves x minus 5 halves times 0 equals 15. This piece turns into 0. So I'm left with 3 halves x equals to 15. Now, to solve for x, I need to divide by 3 halves. On the left side, the 3 halves are going to cancel and be left with an x. On the right side, I'm going to yank out my calculator because I don't want to do that by hand. So I'm going to go 15 divided by parentheses 3 divided by 2, and I get 10. So 10 is going to be the answer here. If I wanted to do this nicer, this side right here, I could have thought of this as 15 divided by 3 halves, and that's the same as 15 times 2/3, and then this 3 and that 15 would cancel. The 15 would turn into a 5, the 3 would be gone, and I'd multiply 5 times 2 and get a 10. So part of my answer to number 8, the x-intercept, is going to be the point 10, 0. I'll do the same thing for the y-intercept. So for my y-intercept, I'm going to plug 0 in for x and go 3 halves times 0 minus 5 halves y equals to 15. This piece is 0, so I'm left with minus 5 halves y equals to 15. I need to divide both sides by minus 5 halves. On the left-hand side, I'm left with a y. And on the right-hand side, I'm going to use my calculator to go 15 divided by parentheses negative 5 divided by 2, and I get negative 6. So the y-intercept, the y part of the y-intercept is negative 6. The x part is 0. In for my answer, that would be all the work I need to show. This part right here, if I wanted to do it by hand, to go 15 divided by negative 5 halves, that's the same as 15 times negative 2 over 5. And I could cancel, that turns into a 1, that turns into a 3. I'd multiply the 3 and the negative 2, and I'd get that negative 6. 9 and 10 want me to figure out the symmetry, and I have to show work. If I just write an answer down and don't show the proper test, then I'm not going to get full credit. And when we did the video over this, what we did is we solved the equation for y, we graphed it, we figured out what kind of symmetry it had, and we did the appropriate test. Usually if an equation has x squared, it has y-axis symmetry. If an equation has y squared, it has x-axis symmetry, and that's the two that are on the review. So let me go ahead and take this equation and solve it for y, so I can graph it on my calculator. And this one's real easy to solve for y. When I solve it for y, I get x squared plus 4 equals to y. I'm going to go ahead and graph this and see if it looks like the graph has y-axis symmetry. So in my y equals, I'm just going to put the equation x squared plus 4. I have no idea what window I had previously, so I'm going to hit my zoom button and then go down to number 6 and hit standard to sketch a graph. When I look at the graph, I have to ask myself, in this case, does the y-axis cut it into 2 equal halves? And it certainly looks like the y-axis cuts it into 2 equal halves. So I think my answer to the type of the symmetry this has is it has y-axis symmetry. Because a line through the y-axis would cut it into 2 equal halves. And it says here you need to show work you make sure to perform the appropriate test to confirm your answer. 0 points for correct answers without work. So let me do the work. The test to confirm the y-axis symmetry is to replace the x with a negative x and then to simplify. So my test is going to go like this. I'm going to take the x in the problem, I'm going to change it to negative x, put it in a parentheses, and now clear that parentheses. Negative x squared means negative x times negative x. On the left-hand side, when you multiply two negatives, you get a positive. When you multiply two x's, you get an x squared. Because this is exactly the same as the original problem, I know for a fact my graph has y-axis symmetry. That's all we need to show. We need to sketch a graph on our calculator to make sure it looks like it has y-axis symmetry, meaning a line through the y-axis would cut it into equal halves, and then do the test. And the test is super simple. Take the x, change it to negative x, and just do those two lines. Problem 10, because it has a y squared, it's probably going to have x-axis symmetry. I could even show you that without graphing. The proper test to confirm this, the test for y-axis symmetry, the test for x-axis symmetry is to change the y to negative y and simplify. And if it simplifies to be the original problem, then when I graph the equation, a line drawn through the y-axis will cut it into equal halves. And changing the y to negative y gives me negative y squared equals to 5x plus 1, which means negative y times negative y equals 5x plus 1. Negative y times negative y is positive y squared. Because when I put negative y in for y and simplify, it gives me the original problem, I know it has that symmetry. I'm completely done with the problem. Let me show you on my calculator the symmetry. And on my calculator, I can't enter y squared equals 5x plus 1. My calculator requires an equation to be solved for y in order to graph it. So I'm going to have to square root in order to get my calculator ready for this. When I square root y squared on the left side, I get y. And on the right side, I put a plus or minus the square root. And if you remember in the videos over this, to do the y-axis symmetry, you're actually going to have to enter a y1 and a y2, one with the plus and one with the minus. So I don't have to do this, it's completely optional, but if you want to visually see that this has x-axis symmetry, you can do it like this. So in for my y1, I'm going to do second square root of 5x plus 1. And in for my y2, I'm going to do negative second square root 5x plus 1. And when I graph these, you'll see a graph that looks like it has x-axis symmetry because a line that goes through the x-axis will cut it in equal halves. To have x-axis symmetry, the line that's drawn through the x-axis will cut the graph into equal halves, and that's what it does there. Just a few more problems left, and these problems we do in intermediate algebra, so if you haven't forgotten your intermediate algebra, good things will happen here. So first I need to come up with an equation for with a k. Second, I need to solve for k. Third, I need to answer the question. So there's 3 steps. 1, create an equation with a k. And then second, solve for k. And then third, kind of answer the question or use the last sentence. So first bit is going to help me get the equation with a k. The first letter I'm going to write is m followed by an equal sign, and when I see the word varies inversely, I know I get a fraction with a k in the numerator. So inversely fraction k in the numerator. So to the right of the equal sign, I'm going to form a fraction with a k in the numerator, and what goes in the denominator is something that's equivalent to the square root of n. I know that a square root is this symbol, and then the square root of n, the n has to go under it. Done with the first sentence, done with the create an equation with a k. I'm going to move on to the second sentence and do the second part. Specifically, I'm going to know that m is 4 when n is 25. So for this m, I'm going to plug in 4. And for the n, I'm going to plug in 25. Usually for inversely's, we solve by cross multiplying, and that's going to be exactly the case here. I'm going to set the left-hand side up for cross multiplying by writing it as 4 over 1. I'm going to simplify that square root over 25 into 5, and now I'm going to cross multiply. When I cross multiply, up I get 1 times k, down I get 4 times 5. So I've solved for k, I've got k equal to 20. On to the last step, answer the question, and the answer the question's in the last sentence. It says find m when n is 16. So I'm going to find m, I'm going to write m equals, and in for k, I'm going to plug 20. And in the last sentence for n, I'm going to plug 16. So my answer to this question is going to be when I take the answer for k that I got in part 2, and the number for n that's given in the last sentence and plug them in. I'm going to get m is 20 over the square root of 16, which is m is 20 over 4. My answer to this problem, it's the only thing I need to show, is m equal to 5. I don't have to show the initial equation that I created. I don't have to show the answer to k. If you put those answers in your problem, I wouldn't take points off, but they're not necessary. So 12 is a jointly, and a jointly is multiply with 2 letters after the k, as opposed to directly, which is multiply with 1 letter after the k. So there's 3 types of variation. Inversely we just did. Inversely is a fraction with a k in the numerator. There's directly, which is multiplication with 1 letter after the k, and there's jointly, which this is, which is multiplication with 2 letters after the k. So same 3 steps. 1, create an equation with a K. 2, solve for K. 3, answer the question. So step 1 is to go through the first sentence and come up with an equation with a K. So y varies jointly, so I'm going to write the letter y equal, and then I always get the K in first, and there's no fraction there, so I've got my K down. And then it varies jointly as the cube of x. Because it doesn't have a root, that cube becomes an exponent of 3. And then the square of z. Because there's not a root, that square becomes an exponent. If it said square root, the z would be under an exponent, under a radical sign. So that's the first sentence. I've created an equation with a K, and it had straight multiplication with 2 letters after the K. That jointly told me my equation was going to have multiplication with 2 letters after the K. The words cube of x and square of z gave me the letters that came after the K. Now I'm going to solve for K by plugging in 144 for y. I'm going to plug in 2 for x. And I'm going to plug in 3 for z. And then I'm going to simplify this a little bit. I'm going to do my exponents on the right side first. 2 cubed is 8. 3 squared is 9. So the left-hand side simplifies to be 144 equals k times 8 times 9, which is going to give me 144 equals 72k, because the 8 times 9 is 72. And now I'm going to divide both sides by 72 and get 2 equal to k. Done with the second sentence, moving on to the last sentence. For the last sentence, I'm going to use my equation. I'm going to write y equals, and in for k, I'm going to plug 2. In for x, I'm going to plug 3. And in for z, I'm going to plug 2. So I'm finding y when k is 2, x is 3, and z is 2. This is going to give me y equals 2 times 27 times 4. And I don't want to do that by hand right now. I'll probably mess it up. So 2 times 27 times 4, which is 216. So the answer to number 12 is just 216. It's actually going to be y equal to 216. So for my answer, it's going to be y equals to 216. Apparently, problem 13 is just another problem from your homework that I might have done in the video, or you may have done already. So this is the same 3-step process. Create an equation with a k. Solve for k. And then answer the question. It's not really even a question, but I'm going to create an answer. So, first sentence gives me an equation. So, suppose the demand, first letter I see is going to be the first letter I write followed by an equal sign. So, the demand for candy at a movie theater is inversely. I see inversely. I'm going to create a fraction with a k in the numerator. And it's related inversely to the price. So, that whole first sentence is going to give me my equation with a k. As I read through this, first letter I see is d, so I wrote a d followed by an equals. Next thing I saw was an equal sign, so I created a fraction with a k in the denominator. The last thing I saw was the letter p, and I have to look before p to see if there's any key words like root, cube, square root, cube root. There aren't any key words, so this p is just going to be a plain ordinary p. Done with the first sentence. Now I'm going to go on to the second sentence and solve for k by cross multiplying. So the first number I see in the second sentence, the price is $2.75. I'm going to plug in $2.75 for the price. I'm solving for k, so I'm going to leave the k alone. And then it says when the theater sells 156 bags of candy, that's the demand. So that's going to be the D. So what I need to solve is 156 equals k over 2.75. I'm going to do that by cross multiplying. I'm going to write the 156 as a fraction, and then I'm going to cross multiply. When I cross multiply, I get 1 times k equals 156 times 2.75. And that's going to give me something for k that I'm going to get on my calculator. So I'm going to go 156 times 2.75, and I get 429 for k. Now I'm going to move on to the last sentence. I'm going to go d equals, and in for k, I'm going to plug 429. Done with the second sentence, on to the last sentence. Determine the number of bags of candy that will be sold when the price is raised to $3. That $3 is going to be my price. So I put the 429 in for k, the number in the last sentence 3 in for p, and now I'm going to solve by just going 429 divided by 3, and I get 143. Might be nice if I said 143 bags of candy will be sold when the price is raised to $3. For my answer, I'm just going to say 143 bags of candy. It's everything for number 13. Fourteen's the same 3 steps. First sentence, come up with an equation with a k. So first step, take that first sentence. I need an equation with a k. First letter I see, the distance d, I'm going to write d equals. It takes a car to stop as directly. Directly as multiplication with 1 letter after the k. So immediately I get my k in the right-hand side. I don't need a fraction, so I'll keep going. And then it's directly proportional to the square of the speed. The letter I need after the k is an s, and the word square that becomes right before the s tells me I need an exponent of 2. So the equation is going to be d equals to ks squared. Now I'm going to get into the second sentence, and I'm going to solve for k. I solve for k by plugging the numbers from the second sentence in. The first number I see in the second sentence, a car traveling 10 miles per hour, that's the speed. So I'm going to solve for k. I'm going to plug 10 in for the speed. A car traveling 10 miles per hour can stop in 15 feet. 15's the distance. So I get 15 equals k times 10 squared. This is going to give me 15 equals 100k. And then I'm going to divide both sides by 100. And I'm going to use my calculator because the decimal is going to be nicer than the fraction for me. So 15 divided by 100 is 0.15. So I got 0.15 equals to k. Last sentence. So I'm done with. First sentence gave me an equation for k. Second sentence gives me some numbers to solve for k. Last sentence helps me answer the question. So in the last sentence, how long will it take to stop a car traveling 40? How long will it take a car traveling 40 miles per hour per stop? I'm going to put the d down. I'm going to put in equals. In for k, I'm going to plug 0.15. And the number in the last sentence is the speed of the car is 40 miles per hour. So in for that s, I'm going to plug 40. And now I'm just going to use my calculator. I'm going to go 0.15, well, 0.15 times 40 squared, and I'll get 240 feet. My answer, I can just say it's 240 feet, maybe to stop. If you just wrote 240 feet, I can completely live with that. The last 3 problems give me graphs, and they ask me to figure out the kind of symmetry. Let me make problem 15 a little bit bigger, because that's the trickiest symmetry for students, and I'm not sure why. So a graph either has x-axis, y-axis, or origin symmetry. To have x-axis symmetry, a line through the x-axis needs to cut it in equal halves. Problem 16 is your classic example of x-axis symmetry. The answer to problem 16 is that it has x-axis symmetry. There's no algebra to do. You're just supposed to be able to look at the graph and realize that a line drawn through the x-axis will make it the equal halves up high and low. That's not the case for problem 15. For problem 15, the line drawn through the x-axis doesn't give it x-axis symmetry because there isn't a mirrored part above the x-axis for this half, and there isn't a mirrored part below the x-axis for that half. So 15 doesn't have x-axis symmetry because there aren't equal halves above and below the x-axis. Problem 17 is what y-axis symmetry looks like. A vertical line drawn through the y-axis cuts it into a left and a right half, makes y-axis symmetry. So problem 17 has y-axis symmetry, and that's the answer to problem 17. Problem 17 has y-axis symmetry because a line drawn through the y-axis makes it cut into two equal left and right halves. 16 has x-axis symmetry because a line drawn through the x-axis makes an equal top and bottom half. Problem 15 doesn't have y-axis symmetry because in order to have y-axis symmetry, this part right here would have to have a part there. This half right here would have a part there. So problem 15 doesn't have x-axis symmetry. It doesn't have y-axis symmetry. The kind of symmetry it likely has is origin symmetry. And what we did is we said, if we take the graph and flip it upside down, if it looks the same upside down as it does right side up, then it has origin symmetry. And these graphs are supposed to look the same right side up. They look the same upside down. And when a graph looks the same right side up and upside down, we generally say it has origin symmetry. I could probably create a graph that doesn't have origin symmetry that looks the same upside down as right side up, but I wouldn't do that on a test, and I'm not really sure exactly what it would look like anyways. So the answer to 15 is origin symmetry. So a lot of students miss these on the test, and they should be real easy to figure out the symmetry. Parabolas on their side generally have x-axis symmetry as long as the x-axis cuts it into two equal halves. Parabolas that open up or down usually have y-axis symmetry on our test as long as the y-axis cuts them to equal halves. And these little squiggles usually have origin symmetry. Again, I could make graphs that are parabolas that don't have any symmetry, but as long as the vertex is on an axis, it's going to have some symmetry. All right, that's everything we need to know for Chapter 2 in terms of the test. So if you can just perfect these 17 problems, you should do really well on our first test.